Okay, simultaneously in equations, similar to a 2011 VCAR question. Now, these are common, they occur a lot in exam 1 as well as exam 2. So it's important when we go back to the beginning of the year and how to do these types of questions. So, two simultaneous equations, find the value of k for which there are infinitely many solutions. And so what we're thinking about is each of these equations is a straight line, and for infinite solutions, essentially they'll be representing the same straight line. Now, if there was no solution, then we'd have two lines that are parallel, but which never touch. And of course, the final option would be a unique solution where they will cross, because they would have a different gradient. So, to begin with, for infinitely many solutions, we need to consider the determinant. Now, for there to be a unique solution, the determinant must exist. For infinite or no solution, there's not going to be a determinant. So what we need is, I shouldn't say there's not going to be a determinant, but what we need is for the determinant to equal to 0. Now, to find determinant, I like to put this into matrix form. So I've got k take 2 and 4. I've got 3 and k plus 2. This is in my 2 by 2 matrix. In my 2 by 1, I have x and y. And this will then multiply to give me 6 and 2k plus 1 in a 2 by 1. And if I multiply out this matrix, I'll get my two equations. And so for the determinant equals 0, it's going to be AD take BC equals 0. So k take 2, k plus 2, AD, take away BC, equals 0. Now, as soon as I do this, I recognize that I have a quadratic. So to solve it, I'm going to use null factor law. I know sometimes people like to try and start taking numbers over here and they're using different things for quadratics, but null factor law is always going to be my first option. So I've got a difference of squares here. So I've got k squared, take 4, take 12. So k squared take 16 equals 0. So I've got k plus 4, k take 4 equals 0. So k is negative 4, or k is 4. Now, one of these will give me infinite solutions, one of these will give me no solution. So I do need to test them out. So let's test negative 4 first. So sub negative 4 into the original equations. So if I sub in negative 4 for k, I've got negative 6x plus 4y equals 6. And let's do it here. 3x, take 2y, equals negative 7. What I like to do is I like to make y the subject, because then it's in general form and I can see the gradient, I can see the y-intercept, and it's quite easy then to determine, firstly to make sure that they're parallel, but then to see are they essentially representing the same line or are they different parallel lines. So if I make y the subject here, I've got y is 3 on 2x plus 3 on 2. If I make y the subject here, I've got y is 3 on 2x plus 3 on 2. Plus 3 on 2, sorry, plus 7 on 2, plus 7 on 2. Ordinarily I'd be using pencil. I'm using pen just so that it's easier to see on the video. Sorry, 7 on 2. So at this point in time, we have the same gradient and different y-intercepts. So I'd say these have no solution. I am going to test by subbing the other k value. So sub k equals 4 into the original equations. So here I'll have 2x plus 4y equals 6. Here 3x plus 6y equals 9. Same process, I'm going to make y the subject for each of these. So over here I've got y is negative x on 2 plus 3 on 2. And over here I've got y is equal to negative x on 2 plus 3 on 2. Okay, so here we have the same gradient and the same y-intercept. So I'm happy that when k equals 4, we have infinite solutions because these are representing essentially the same line. So therefore, infinite solutions when k equals 4. And no solution when k equals negative 4. Now for down here, find the values of k for which there is a unique solution. Now for a unique solution, we know the determinant does not equal 0. So, as the determinant does not equal 0, the inverse exists. So for a unique solution, we're going to say that we had this before here. We had k plus 4. K take 4 does not equal to 0. And so what we need to say is we need to say that k does not equal to negative 4 and k does not equal to 4.